Hello and welcome to part 2 of today's lesson. So a couple of things that we should know about similar triangles. We know that in similar triangles, all corresponding angles are congruent, but the corresponding sides are proportional. And we are going to look at the scale factor in finding missing values of our triangles. So again, similar triangles, that means that angle Q is the exact same value as angle E, just like angle R is the same value as angle F, and angle S is the same value as angle G, again, because corresponding angles are congruent in similar triangles. However, corresponding sides are proportional in similar triangles. So again, these aren't congruent, these are similar. And we already looked at our scale factor in this example from our first video. If side QR correspond with side EF, and this first value was 3, and our new value was 6, then we know we had a scale factor of 2, because we can tell that our original triangle, this orange one, got bigger to get to this blue triangle here. So the way we're going to find our scale factor is we are going to set up a ratio of our new measurement of our sides over our old measurement. So our new meaning our blue triangle over our orange triangles measurement. So let's start with our first corresponding side, QR to EF. The new side would be EF, and we know that measurement is 6. The old side of our corresponding triangle would be QR, and we know that measurement is 3. And so that is the ratio of leg EF to leg QR. So all we did was set up a ratio. We can do that with the other corresponding sides. Let's take a look at FG. FG is our new triangle, and that measurement was 8. And it corresponds with side RS, and that measurement was 4. And then lastly, when I look at my hypotenuse, EG was 10, that's our new. And QS was 5, that's our old. So we use this new to old ratio across all 3 corresponding sides. And as we go to simplify these fractions, we're going to notice that when I divide 6 by 3, I get 2. When I divide 8 by 4, I get 2. When I divide 10 by 5, I get 2. And so in addition to using angles to prove that these two triangles are similar, I can see that our scale factor is consistent among all 3 of our corresponding sides. And since all 3 corresponding sides are proportional, then I know that these two triangles are similar. And our scale factor, we'll use SF, our scale factor for this triangle was 2. You might also see that written as 2 over 1, but again, remember 2 over 1, the whole number, is the same thing as the fraction 2 divided by 1. So we are going to use our scale factor to help us find missing values of triangles. And so we're going to have to use proportions. Since we know that these two sides of these triangles are proportional, we're going to use that to our advantage. So here we have 2 triangles, this pink and this green, and I know that these are similar triangles because 2 of my angles, corresponding angles, are congruent, right? This angle, and that's enough information to tell me that these 2 triangles are congruent because I know that this third angle is congruent to this third angle because, again, they have to add up to 180 degrees. So we are going to use the same new to old ratio, new over old, to figure out our missing value. So if I'm taking a look at my green and my pink triangles, my new triangle is actually this green one. So I'm going to set up a proportion. Actually 2. And I can tell that since this top angle is congruent to this top angle and this one to this one, I know that 12 and 3 belong together. So they are going to make our first ratio. And if I start with my new, that would be my green one, then my new value was 3 and my old value was 12. But they are the corresponding sides of these similar triangles. I'm going to do the same thing for this, but this time I don't know what this value is. I'm asked to find x, but I do know it corresponds with this 20. So if I take a look at this x, and that's what I'm looking for, I can put an x there to represent my unknown, and x and 20 are corresponding sides. So right now I have created two ratios, 3 over 12 and x over 20. But if I go back to this, I knew that all three of these ratios were equal to each other because they were similar triangles. I'm telling you that these two are similar triangles, and what that tells me about these two fractions or ratios is that they're also equal to each other. And so I can use proportions to help me solve for x. So when I'm solving for x, I'm actually going to cross multiply. I know some of you go up and around. I'm just going to go straight down. 3 times 20 is going to give me 60. And x times 12 is going to give me 12x. And again, this is like an equation, but this isn't an equation. I'm going to bring down my equal sign. And when I get down to here, I'm actually going to use inverse operations. If 12 is attached to x by multiplication, then the inverse operation would be to divide by 12 on both sides of my equation. Well, 12 divided by 12 will leave me with 1x, which is what I'd like. And then if I take a look here, 60 divided by 12 is 5. So I know that this missing side is 5 units. To prove that, I can use the same ratios. So again, 3 over 12, 3 divided by 12, should be the same as 5 divided by 20. And when I simplify these fractions, again, 3 and 12 have a common factor of 3, so I could divide both the top and the bottom by 3. My new fraction will be 1 over 4, which would be my scale factor. The same thing is true with 5 over 20. I could divide 5 by 5 and 20 by 5, and that will leave me with 1 over 4. And so I'm actually noticing that these two triangles have a scale factor of 1/4 from our pink to our green triangle, which makes sense because our triangle got smaller. So there's two ways you can do this. You can set up a proportion, which we just did, and we actually use cross multiplying at first to solve our equation to get x equals 5, so we already had our missing value. But to prove that, you can actually use your ratios and simplify them to show that your scale factor was 1 over 4.